好，谢谢。Um, we have 1 week apart, and um, I recommend you brought your notes. Um, today we will review this stuff. It's a lot of, and we will do the questions on the book. We will do the questions on the book. Did you bring your textbook? Good, good. Um, and next week, um, I think I cannot make it because I have to go to Shanghai for a business trip. Shanghai? Yeah, Shanghai for business trip. So next week, no linear algebra class. We will find the time to make up the class later. Um, um, the norm is I is on the page P20. This is a review already. You know, is talking about the length of the vector. Is very similar to our elementary school stuff, absolute value. Absolute value. In in elementary school, the two bars is means the distance to the origin, and doesn't matter which direction it is. They are both equal. They are equal to 3. So we don't care the which way. Sometimes it's useful, right? Mathematician invented the absolute value is because sometimes we need it. Sometimes we need it. Absolute value. And for the norm, vector norm is normally vector has a direction. This is -3 with 3, just in one dimension. Just in one dimension. Is it backward or is it forward? For vector, it can be not just one dimension. It can be 2 dimensions on the plane. Could be pointing there, could be pointing there. Could be 3 dimensions. Could be pointing there, could be pointing there, could be pointing there. This is a 3 dimension. Sometimes then we don't care the direction. Sometimes, okay? We don't care direction. We only care the length. We only care the length. The length, math term is a fancy term for the norm. Okay? So we only care them. So this is a symbol because we are in advanced level. So we put two bars on each side, not just one bar for absolute value. This is elementary school stuff, one bar. And here we want to make recognizable the difference, not confusing, not confused with. We don't call the absolute value of a vector. We don't call absolute value of a vector. Even though you can think about, you can think and say, oh, that's absolute value of a vector. We get to throw away the direction. We throw away the direction. We only want the value, the length. Is this far or is that far? We do not care. Is it pointing there? Is it pointing there? Or is it pointing there? We do not care. It's not just three dimension. Vector can be 4 dimension, like we said. Can be 5 dimension. Can be 6 dimension. Can be 100 dimension. Or even tens, thousands of dimensions. And so this is their uniform, the formula. But you understand the meaning is more important. You understand the meaning is more important. And this is kind of like going hand by hand. Dot product. What is a dot product? Is I can you fill in which page? Okay, which page? Dot product. Dot product. Which page? Page 18. Page 18. Page 18. Also definition. This is Dr. Lee's gift. Okay, I give this to you. Present. This one. This is from the textbook. This is hinted in our textbook, later pages. But I would prefer to make it standing out. Make it standing out. Next to there is a formal, this is a government definition. This is a government definition. And this is more meaningful. They are equal. They are equal. The proof we skip, okay? Well, we skip. But in today we will do a lot of exercise. Be prepared, or you will do it. From the questions are from our textbook today, and you will see sometimes they use this, sometimes they use that. Interchangeable, to see which way is more convenient. Is more convenient. Dot product. Back to the norm. It's dot by itself. Okay. So sometimes we use this. Sometimes we use this. Is a square is equal to It's dot itself. This is the same thing, okay? You will see in the question. In a couple minutes, we will work on it. Is it dot itself? You need to understand why is a distance, it's a length square, is the vector dot itself. Here, you will see if we replace this u by v, okay? If we replace, so this is a v, okay? Dot v and equal to v. So here the square comes out. Do you see it? Do you see it? And the cosine, this is the two vectors angle, okay? Could be this, could be this. And very important, very, very important, could be this. Vertical, very, very important. Vertical. Okay, we focus on this question. V and V, what's the angle?
0.
What's the angle? Two vectors are the same. What's the angle between the two? 0. Okay? Two vectors are the same. What's the distance between you and yourself? What's the distance between me and myself? It's 0. Here it means talking about angle, not distance. But the two are same. Okay, the same. So it's 0. Doesn't matter. Okay, let's say 0 degree. 0 degree. And can you tell me cosine 0 degree is what? It's not 0. It's not 0. It's not 0. Are you sure?
0 degree equal to 1.
What's the cosine 0? What's the cosine 0? Unit circle. Unit circle. Okay. That's starting from a random, a simple angle. Okay. Here is the angle theta. Where is the sine theta? Where is the cosine theta? Where is the sine theta? Sine theta is this red one. Browsing your nose. Browsing your nose. Okay. Sine theta is the movie screen length. We are in a dome. We are inside a dome. Like US Capitol. Inside a dome. The movie screen height, that is sine theta. The movie screen distance to my foot, that is a cosine. This part is a cosine. You need to know the unit circle very well. You need to know unit circle very well. Okay. Now let me put, if this one is, I put the angle smaller and smaller, becomes 0. What is the sine 0?
1.
The red one, the movie screen, now is on the floor. Sine 0 is 0. The movie screen is completely drop to the floor. So the red part becomes 0. This is a sine 0. You can say 0 degree or sine the distance, or you can talking about the distance, the arc length. That is 0. Okay? What about cosine 0 degree? What about cosine 0 degree? Is pushed to the furthest in the dome. Okay? If this angle, then the moving screen is over here to the floor. Okay? If it's completely flat, then the movie is over here. That is 1. Cosine 0 is 1. The unit circle helps you very importantly. Okay. Now, if the angle theta, I'm curious, how many people can you see the theta from back? Can you see? I have very bad eyes. Yeah, I'm jealous to your guys' good eye. If the theta become 90 degree, okay, 90 degree, what is a sine 90 degree? What is a sine 90 degree? The movie screen, you can see the progress, okay? The red one become, the height become taller and taller. Eventually, it's right above my head. And the hitting the tallest point of the dome. At the 90 degree, the movie screen, the red movie screen, the height is 1. Okay, this is unit circle. Okay, so this is 1. So sine 90 degree is what?
1.
Okay. And the cosine 90 degree is what?
0.
Yes, it's 0. This is very important. So when the two are vertical, this is a 90 degree. This is 0. If it is 0, then everything is 0. So when the two are perpendicular, no matter is this or that, doesn't just the perpendicular or these. If the two are perpendicular, their dot product is 0. Doesn't matter where. Like this. Okay. If the perpendicular, this is 90. Okay? 90 degree. So that's 0. And I'm preparing for the questions you guys will facing in a couple minutes. If the angle is more than 90 degree, if it is more than 90 degree, it's here. You just tell me the cosine theta is a positive or is a negative. Is that a positive or is it negative? Now, which one is sine? Which one is cosine? Oh, doesn't show red.
positive.
For this bit, let's say theta gamma. Gamma. Cosine gamma is a negative. It's this part because it's this part. It's on my back. It's always the distance on the floor. In front of me is a positive. On my back is a negative. For sine is still positive. The movie is still hanging there. The movie is still hanging there. And for this angle, if it's more, if it comes to here, this is alpha or gamma. Let's say this is alpha. Sine alpha is a positive or is a negative?
Negative.
Right. Now is on in the third. Okay. How about cosine?
Negative.
How about cosine?
Negative.
Cosine. Where is cosine alpha?
Right side.
Is this part? Is this part? Okay. I do not want overlapping here to see. So it's a negative. So it's a negative. So sine is a negative. Cosine is also negative. Sine is negative because the movie screen is in the dirt. The movie screen is in the dirt. Cosine is negative because the distance. They are hanging on my back. They are hanging on my back. Cosine is the distance on the floor. Okay, it's on my back, then it's negative. Okay, if it's here, if it's turned over here, beta, I call this angle beta. Can you tell me positive or negative sine and cosine?
Cosine
Alpha,
positive,
beta,
sine
beta.
negative.
Huh?
Sine negative, cosine positive. Cosine positive.
Sine
Negative.
is negative. Good. Because the movie screen is in the third. Is in the third. It's in the third, in the basement. How about cosine beta?
Positive.
Is that positive or is it negative?
Positive.
Right, it is a positive. Because even though it's in the third, the distance to me is in front of me. It's in the third, but the distance is over there. Okay, so if later in the question, if you find two angles, if you find the two, we don't know what angle it is. If you find this is positive, that means the two is what's the term? Abuse? this. And if you find this is negative, then obtuse, that is over there. So they were asking you the two vector, are they in this or are they in this? Remember that term? I'm not too familiar with its English term. It's
Acute angle.
yes, yes. How to say?
Acute angle of angle.
Yes, acute. Um, yes. On page 29, on page 29, page 29, exercise 18 to 23. Exercise 18 to 23. Page 29. Do it now. Do 18, 19, 20. 18, 19, 20. Can you tell me the angle is acute? This is called acute. This is called obtuse. Acute. And another one, my favorite. This one. Right. Right angle. I don't draw it here. Do I need to write down? Page 29. Question 18, 19, 20. Do it now. Somebody stop the recording for me. Stop the recording for me. Is the recording?
Yes.
Okay. Okay, we stop. Okay, we stop. And the vector norm, okay, vector norm is its length. Can you, in last class, couple minutes ago, we saw the two vectors, the dot product is 0. Two big, two big vectors. When I do the dot product, becomes 0. Becomes 0. It's amazing when I do this vector dot this vector becomes 0. That means the two. That means if this is 0, the left side is 0. These are two big guys. These are not 0, like I said. They are pointing over there and pointing over there. So this proves that this angle is 90 degrees. Is 90 degrees. This is the power of math. This is the power of math. This we can visualize it for more complicated vectors. Then we cannot even visualize it. but it doesn't matter. If the dot product is 0, if there's nobody is 0, so we know this is not 0, and the only chance to make it everything 0 is this guy, cosine. Is a cosine, the angle is 0. Trigonometry, okay, trigonometry. If this is 0, then this is a 90 degree. This is a 90 degree. Okay. This is talking about perpendicular. And the other cases, like the question was asking, is acute less than 90 degree means acute. Obtuse means greater than 90 degree, but less than 180 degree. Okay, less than 180 degree, greater than 90 degree. So they're asking the two vectors in question 18, question 19. We did 20. So can you finish 18 and then 19 now? Can you finish 18 and then 19 now? And so how to tell the theta is less than 90 or greater than 90 degree? Fortunately, if it's greater than 90 degree, then the cosine is negative. This is a negative. Okay? This is a positive, this is a positive, this is a negative. If the theta is greater than 90 degree, this is a negative. Positive, negative. So the dot product should be negative. Okay? So you use this formula. Bam, bam, bam. Okay? Bam, 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 bam. Now calculate the dot product. If it's negative, that means this little guy is a negative. That means this little guy is a negative. This means is a greater than 90 degree. Is a greater than 90 degree. Cosine is a negative. If the dot product is a positive, so this is positive, okay? This is absolute value of vector. Then this is a positive. Then this is a beautiful angle like that, acute, less than 90 degrees. Page 28, question 18, 19. Question 18, 19. 25 is a part of question 19. They want you find out the exact angle. Stop recording for me. Somebody stop recording. 谢谢. If you have questions, if you have questions? No. Let's turn to the book, page 25. Example 1.22. Page 25. Example 1.2. This is also trying to find out the angles. The angles. Okay. Let's imagine I borrow our classroom as a cube. Let's say over there, okay? Over there and everything. Let's say it's a cube. A cube. Cube means the square. Each side is equal. Okay? This side and this side over there and this side are equal. Three sides are equal. They are not rectangle. Okay? Are you following me? I cannot bring a tofu. I bring a tofu and try to make it a cube. Say, okay, it's too much water. Okay. Yeah. So the question, this question saying, let me make it say, let's say the distance is 1, okay? From here to over there is 1. From here to there is 1. And from here over there is 1, okay? So, from here over there, let's say there's a vector. That's vector. And what's that vector? This is the origin. So, let me start from here over there. This is x, okay? This is x. This is a y. This is a z. The vector from here over there. Can you give me its value? It's not moving at all. It's a flat over there. So the first number is 0. Okay? First number is 0. And the second number is 1. It's moved over there. The third number is also 1. So this vector from their origin to that corner is 0, 1, 1. It's it's the first vector on the book, 0, 1, 1. The vector over there is 0, 0, 0. Origin is 0, 0, 0. Okay. From the origin over there, the vector, what's the vector? 1, okay? 1, and 1, and 1. So this vector from here over there is 1, 1, 1. The question doesn't use this vector. I just bring here to help you understand what I'm talking about. Are you following me? Yes. From here over there. 1, positive 1, okay? 1 here, and move 1 over there, and 1 over there. Following me? 1, 1, 1 is from here over there. Okay? Now the vector from here over there. Can you give me? Huh? 1. I'm not moving anything because it's a minute. So it's 1. It's 0. Okay? I'm not moving over there. I'm not going inside the wall. Okay? Now I'm going up. I'm not going down. Okay? It's going up. So this vector from here over there is a 1, 0, 1. The question this book was asking the angle between here and there. The angle is not 90 degrees. It's not 90 degrees. Here, I cannot use the red paint to draw that. The university will say, oh, Dr. What are you doing? Okay? But you can imagine, I use some painting, okay? This diagonal and this diagonal. The book was asking, what's the angle between the two diagonals? I can tell you the answer because it's also on the book. It's a 60 degree. Over there and over there is a 60 degree. Yeah. In high school, to prove this diagonal and that diagonal is 60 degree, I remember it's a headache. It's a headache. But in here, we use this, we can prove easily. We can prove easily. It's clean. So the two vectors, let me bring the two vectors together, then we take a break, okay? I erase this part. So this vector is 0, 1, 1. Okay, 0, 1, 0, 1, 1. That vector is a dot product. Is a 1, 1, 0, 1. We dot it. What's the result? 0 times 1, that's easy, okay? 0, 1 times 0, that's easy. 0 is a 1, okay? So it's a 1. So we know on the left side is 1. What's its norm? What's its norm? Let's say this is U. Okay? This is a V. What's its norm? I heard somebody say 1. Where 0 squared plus 1 squared plus 1 squared. Okay, so it's root 2. Root by 2. Anyway, you know that the inside a cube. This is 1. This is 1. What's the diagonal? Root 2. Right? Pythagorean. This actually is a Pythagorean. Okay? So the painting I'm drawing, okay, is root 2. If this is 1, okay, that is the square root 2. And here, this one is this one. This one is over there, okay. And this one, what's this one? Is the same. It's the same. Similar, okay? It's similar. 1 plus 0 squared plus 1 squared. Okay? Is 2. Now we know this. This is a 1, okay? We plug in, okay? This is 1 because here, okay? Now we plug in this root 2, plug in this root 2, and cosine, mysterious, cosine theta, okay? Don't think that because this is 1, then this is 1, okay? Don't do that. Okay, it's not related. Okay, is cosine theta. Is a cosine theta. We are gradually getting close to it's a true phase. This is a math or science. We are getting to the true phase. So what is the cosine theta value? Cosine theta value, this is 2. Okay, move over is 1 over 2. 1 over 2 is still here. If it's 1 is half, if it's half, then this angle is 60 degrees. So this proved. So this is 60 degrees. So this proved. This diagonal and that diagonal is 60 degrees. You maybe feel that maybe it's perpendicular, but no. It's from over there and from there. It's 60 degrees. This is, if we're not using this way in high school, to prove the angle is much more drive crazy. This is very clean, easy. Okay, we take a longer break. Okay. Okay. Stop recording. Okay. Stop recording. 谢谢。